So today we're going to look a little bit at measurement and scaling concepts. So the different ways we can measure, and then how we attribute measurements or values to variables. So how we attribute magnitude to variables, and that's scaling, or how we categorize or classify variables. So what we're going to look at first is levels of measurement. So measurement is the assignment of numbers to objects or events according to sets of predetermined or arbitrary rules. They shouldn't be arbitrary, to frame it more precisely in psychometric terms, and the transformation of psychological attributes into numbers. So I want you to think about all the things you could use to measure the size of this lecture room in a way that would make it understandable to other people. So imagine you're ordering a new carpet. What criteria should the measurement method meet? So say the person who was fitting the carpet was never going to come into this room before they came and fitted the carpet. What would you use to measure? What are the attributes? What criteria should the measurement method meet for you to make sure that the correct size carpet will be ordered? So what would you use to measure this room if you were having to order a carpet for this room? A measuring tape, so you'd write down the different measurements. What scale of measurement would you use? What units of measurement would you use? Centimeters and meters, most likely here. So meters and centimeters, because it would be huge just in centimeters. So if you used centimeters and you used a measuring tape and you maybe drew a diagram and you showed the different lengths, it would be really easy for the person looking at the diagram to see what you wanted. But if you said, well, I walked around the room, which is what we do, I can't walk around, sorry, because the mic. When we're measuring in horse riding, we use our strides. So we more or less know what a horse's stride is, and we use that. But if I walk a stride, it's going to be different from your strides, right? So you have to try and sort of equate strides, and we all have to measure consistently without a proper measurement tool. Now imagine if I walked around and I said, well, it was approximately 4 paces across and 12 paces up. What on earth does that mean to someone over the internet? It's not going to work. And you can imagine that this is far worse if we have a situation where we're working with psychological attributes. So if you said someone was friendly, your idea of friendly might be very different from mine. Yeah. Or if I said that someone was showing signs of stress, I would have a little bit more of an informed opinion than maybe someone else. Someone else might say, oh, that person's just very controlled, self-control, is demonstrating self-control, but I might be looking at listening to their breathing, or seeing the tension in their jaws, or other signs. Because stress isn't always like biting your nails or tearing your hair out. So it's way more important for us. So we want to make sure that we use consistent scales that other people can also apply, and we use them in a relatively fixed manner so that they can replicate whatever it is that we've done. So these are 3 things or properties of measurement scales. The first is magnitude. I'm just going to make this smaller. Sorry, I use an open source software, Office software, and it's not always perfectly like PowerPoint, but it's free. So 3 properties of measurement scales, usually. The first is magnitude. A psychological assessment tends to give us some idea of the strength or magnitude of something. That's not always the case if we're just categorizing things or using ordinal data. In that case, we're just going to give a rank, or we're just going to ascribe labels to things. But for ratio and interval data, you will see that there's a magnitude. The strength of something is evident. So the moreness is evident. Magnitude. Magnitude is strength. You'll hear people talk about the magnitude of an earthquake. It's the strength of an earthquake. Equal intervals. So unlike ordinal and nominal or categorical data, for interval and ratio data, we have equal intervals. We can tell the difference between each. So 2 less 1 is the same as 3 less 2. Yeah? You get to the same number, and the quantities are the same for each interval. So if you look at a ruler, you can see it doesn't jump. All the divisions are equal. Okay, so the differences between the points in the scale are uniform, and you generate continuous data. We started looking at continuous data, so upper real limits and lower real limits, the issue around limits and the fact that we allocate scores, but there's actually stuff going on in between each score. Those are just our arbitrary cutoff points so that we can understand the data better. So that's the other thing. Measurement scales can have absolute 0. So a ratio scale can have an absolute 0. Then there's nothing present of the attribute being measured. With many of our human attributes, though, it's almost impossible to have an absolute 0 point. Okay? Does that make sense? The best example I've heard is talking about a research method test. So say I test you today and you get 0 on that test. Does that mean you know nothing about research method? Just means you know nothing about the questions I've just asked. Okay, very different, right? So it's not absolute 0. It doesn't mean you know nothing about the point. But if we don't have something there, the length of that nothing is 0, right? As opposed to if we have something there, we can measure its length, right? So there can be a 0 in terms of length or something like that. Okay, so sometimes we can have a 0, sometimes we can't. If we're timing something, it's another good example. So say I set my stopwatch and I press go, oops, and then something like that happens, which doesn't usually happen. Oh, that's why it's still running. So if I press that, it gives me a time from absolute 0. That's the time since I started the stopwatch or since the activity started. But if I look at the time and I tell you the time is now 22 minutes past 9, that's not measured from absolute 0, because we don't know when the universe started, do we? Well, maybe they can estimate now, but that's not absolute 0. It's not telling us the time from when it started. It's just telling us the time from when we started this day, which is midnight, right? Makes sense? Okay, good. So, different categories of measurement levels. Measurement helps us to do different things. It helps us to organize things, it helps us to rate them, and it helps us to compare them. So I can organize you according to people who would prefer to watch cricket and people who would prefer to watch football. I can order you from shortest to tallest. I don't know if you had to do that for your photo yesterday, but we did, and it's horribly humiliating being the shortest person in the entire faculty. But that's ordering, okay? So we can order people. We could say, okay, this candidate scored the highest score and is most likely to succeed on the job. This is the shortest person in the faculty. We're ordering people. And we can rate people. So we can rate performance. All our performance management systems work on rating, or should. And then we can compare people. So once we've got all these other scores, we can also say, well, this one's better or this one's better. And we can compare. Or we could create 2 sample groups, an experimental group and a control group, and compare the results. So numbers are also used in different ways. We can name people and we can ascribe numbers. So I think I've got this, and I don't like to jump between programs, you know that, but I'm going to. So this is an actual data set, and here these are different codes. So 3, that's a 3, my apologies for the size, means that this country is from the global north. So that is a code that is attached to a name. So you're going to do the same thing when we capture data from next week. You can then see that if you see a 3 there, it means that that is a nominal label. So we've used the number, let me just find a program. We use the number as a label. Okay. It can also give us a position in a series. Okay, so we can rank things. Now, in the same data, I hope it's still there, or in this program, there's a rank option. I might have removed it. But say I ranked all the countries according to their Human Development Index in 2014. So I sorted it ascending from okay, there's the lowest score in the entire world in terms of human development all the way through down to the bottom to the highest score in human development. Wow, it's pretty high, 94. Let's just see what country that is. And the country is Norway. So in that case, Norway would be assigned a 1, and we'd go all the way through until we got to the worst country in the world, and they would obviously get, I think in my case, in that data set, they'd get the number 214. So we ranked them from the best to the worst. So we can rank people, and we ranked the worst in the world too. So that was countries like North Korea, and Zimbabwe was up there, and I think Somalia, countries where things weren't going too well. Yeah. Those ranks are useful to us. They don't tell us anything about the difference between the countries. There might be like a 20-point difference between the countries, but they tell us who's doing well, who's doing badly. So it can tell us a position in a series. That's what I just demonstrated. And it can also give us quantity to rate or compare, which is pretty cool, and we use that a lot. Again, if we go back there, the magnitude, that HDI value I showed you is actually a quantity, but here these numbers are actual dollar values, so that's average development aid in one country, and that number is 240.670. So it's the number of dollars spent on development aid in a country at a certain time. So we can represent quantity. We can simply say, oh, and if you get $0, that's a ratio. So finance can be ratio. There's an absolute zero. You can have no money. So yeah, we can represent quantity, and then we can rate or compare, and we can do a lot of more advanced stats with the ratio data. So categorical data is the nominal and the ordinal data. I'm not going to continue going into that because you've already done that. It was in the previous video. But the nominal data is a label or a category. Ordinal data, like I just showed you, is a rank order. So we know who's first, second, but we don't really know the difference between them, the quantity. Interval data shows equal differences, so it's got that characteristic of continuous data, but there's no true zero. So something like money is ratio data because it has a true zero. You can have zero money. If you start a stopwatch, you can have 0 time, the time that you started, and then you measure from there. So ratio has equal differences, and you can measure the differences between the different points, and also has a true zero, which means that there's nothing there. There's nothing to measure. Means we can use ratios. Now, errors in measurement. This is something we have to avoid, and this is why we take such pains to validate our instruments, like you did yesterday, to make sure that there are no errors in the measurement, because there are 2 main types of errors, and I hope I'm preempting the next slide. Yes. Okay. So, if we look at our 2 different types of measuring errors, it sounds like measuring arrows, which actually sounds kind of delicious right now. Random sampling errors are errors that occur because of sampling problems, and the error or the difference between that and the mean will change every time we draw a sample. Again, we've already covered this in class. The example was when you go and take this group, and if I pick these guys as my sample, it's going to say that 100% of the sample was male. It's a sampling error. If I take that group, it's going to tell me that 75% of the sample is female. No, neither are absolutely correct because of sampling error. You can see the error is different each time. Here we've overestimated the number of females in the group, and here we've underestimated. So there's a random error. And it'll fluctuate. And if we drew all the samples in the group, that we could possibly draw out the population, eventually the weirdest thing happens. All that random error settles on 0. It equals out, but you'd have to draw every single possible sample. Okay? You need to sort of keep that in, well, you do need to keep that in the back of your mind, because we go back to that. It's part of what we cover when we start focusing on stats more. With systematic error, which is what we were trying to avoid yesterday, and thank you so much, you helped so much, and I'm really actually excited about the research. But with that, the problem is that the error is there and it's consistent. It's always the same. So remember, there were 2 questions that were identical in the questionnaire. Now that's a problem, because what it means is that that element of that opinion will get twice as much had twice as much influence on the score than it should, because it's been entered twice. And for every person, it's going to have twice as much influence. Systematically, no matter how many times we administer the questionnaire, it's going to have the same result. So that's a systematic error. It's a consistent error that we see across the board. Later on, we'll see that we can have different types of systematic errors for different groups. And sometimes this is culture bound. One example was a questionnaire, I don't know if you've completed it yet, maybe we can look at it at some point, that uses the word frazzled. Now just show of hands, how many of you use the word frazzled? I'm so frazzled. 1, 2, 3. Okay, so 3 of us would read that and go, okay, frazzled, yeah, sure. Got that word. The rest of the class would go, huh? How many of you say, no, I'm feeling pretty blue at the moment? Blue. 1, okay, because I'm Eurocentric. I'm an Anglophile. I've stayed in England for a while. Had the misfortune. Never mind. That's a segue we're not going to go in, but it involved an Englishman. And anyway, so things like that will create a systematic error, but it'll be different across groups. So people who are English would be able to respond to that question better than people who haven't been socialized like that. And then what happens? We have bias, right? So one group does better because they understand the language better. And then that group gets all superior and says, oh, well, we're just the best in the world, aren't we? Without realizing that they've made an unfair assessment. Okay. So that's the execution of the research, and that's what we try to avoid. So our measurement scales. Yesterday, you guys did a sample, not a sample, you helped to validate an instrument. And that was a Likert-type scale. Likert. Get used to that word. We use it a lot. The Likert scales are a favorite in psychology. Okay, categorical scales, semantic differential scales. Okay, again, the clue is in the name. That's why I want you to use the dictionary and write a glossary, which is a list of words that are useful. So a glossary, you'd write down semantic, and you might even write down differential. Semantic is to do with words. Differential is difference, so different words. Semantic differential. Okay, so if you see the word semantic, it refers to words. Intensity scales, you know what intensity means. It's the strength of something. Constant sum scales, again, when you add it up, it's a constant, but we'll look at that and make sure. Graphic rating. A graphic is a picture. So if you see the word graphic, you know it's to do with pictures. So a graphic rating scale is a picture rating scale. Forced choice is simply what it says there. You're forced to choose between different options. And then Guttman is a little bit more complicated, but to be honest, I've never actually seen anyone use a Guttman scale. It feels like it's some sort of torturous thing we teach you in 3rd year, and then everyone just disregards completely. Okay, but the Guttman scale exists and is obviously named after the inventor, and the name's not sort of intrinsically helpful in helping you to describe it. So, a categorical scale. This is a frequency scale too, in a way. So, how frequently do you make use of public transport? From never all the way to all the time. Okay? So, that's quite simple, quite easy to use, right? If you were answering that, you'd be happy with that. The Likert-type scale. Here we have a 5-point Likert scale. It's called a 5-point scale because, count with me, there are 5 options. Okay? In South Africa, when I was a young girl, back in the day, my professor told me that South Africans should work with a 5-point scale because it's less complicated than a 7-point scale. But it's nicer to use a 7-point scale because it gives us finer gradation. So it gives us finer levels, and it's easier to respond. If you say strongly disagree, disagree slightly, and disagree, it's better, right? Then if you only disagree a little bit, you've got an option, right? Strongly disagree, disagree, disagree slightly, or disagree somewhat. If you sort of disagree, then you're more likely to choose that option, and you might not choose neutral then. It's an option other than neutral. So 7-point scales do work, but if you're working with a population that doesn't have really high levels of linguistic skills, maybe skills, maybe my linguistic skills are not so good, keep it simple and use a 5-point scale. So you can use a 5 or a 7. Okay, now here's our semantic differential. Yeah.
Just to brief, just go back to the category.
This one?
Yeah. Is it with regards to the, what can I say, the scales that have been used are the words never, really, sometimes? that what changes it or makes it different to the Likert?
Yes, the Likert uses agrees, scales of agree. Yeah, so it's the level to which someone agrees or disagrees or expresses sentiments in agreement with a statement. So usually it's a statement, and then people are asked whether they agree or disagree with the statement. I think there's a lot to be said for Likert scales. They are useful, but we could also critique them. In fact, the categorical scales might be better in some cases. So that is the difference. It's not, yeah. So it's a type of categorical scale, I guess. So semantic differential. This is terrible, right? Because what it says, would you say you're more emotional or intellectual? They're not even on the same scale, right? Or maybe they are. I suppose they're saying on one side you could be more going with your heart, and the other side you're more rational and logical, right? Maybe that's what it's saying. But I know lots of people who are intellectual and emotional. You only need to come to faculty board to see it at work. They get very emotional, right? And they might be great scientists, but my gosh. Anyway, so what you're forced to do is say, well, I'm more emotional or I'm more intellectual. I'm more conventional or I'm more modern. Okay, so traditional or modern. I'm more lazy. Who's going to admit to being lazy, though? This is a terrible instrument. Or more active. And then traditional or progressive, which sounds a lot like conventional and modern. This is okay-ish, but my gosh, I could see measurement error coming in because of how you interpret these items. Okay, that's the other thing. Each of these is an item, so each level is an item. So the questions in a questionnaire or in a survey are items. So intensity scale, how frequently are you in disagreement with your supervisor? From never to always. Yeah. Intensity, how strongly do you feel this? You can see each category isn't labeled there. Okay? Just the two poles are labeled. Okay, constant sum. This you would use, for instance, if you were, in this example, they say it's customer service, but we might ask you, what are the deciding factors when choosing an organization to work for? And we might say organizational culture, compensation, the job itself. And you might have to then decide how important the job is, how important the culture is, and how important the compensation is. And you only have, say, 100 points or 10 points. So you have to say, okay, for me the job is really important. I don't care about the rest. Then it gets like 6 and the other 2 get 2 or whatever. Maybe at the moment pay is more important. So you give pay 7 and you say forget the culture, whatever. So you can see how that works, right? You've got a budget and you have to allocate it according to your preferences or according to whatever factors. Another way of doing this, if I remember correctly, is that you only say you've got a team of people and you're having to evaluate their performance. You could say to each manager, you only have 100 points to allocate, and you have to allocate them amongst the team members in terms of their effort over the last year. So you could say that in terms of effort, this person put in the most effort, and then this person, and then that person. Or you could give them equally the same amount of points, for example. Okay, but if you felt one person did slightly less and one person did slightly more, you could then budget the total efforts or the total outcomes between the people like that. So paired comparison. Now you have to say which is more valuable to you, which you weight more. So which is more important to you, which is the more important value. If you're working with people or you're hiring someone, would you prefer professionalism or integrity? Again, this is one of the problems with survey type research fixed responses, because you could argue that people with high levels of integrity are likely to be professional. Don't those two things go together? Yeah. How can you, if you're a lawyer, how can you be a professional and have low integrity? Not going to work, right? But anyway, so I'm not here to critique the scale. Integrity versus transparency. Competence versus professionalism. See what we're doing there. Okay, a graphic rating scale. You see these in customer service the whole time. How happy were you with HR service today? Press the buttons, or how happy were you with your bank's performance today? Press the button or rate it according to... This is terrible. Whoever designed these slides is really, really lazy, because that should be like an angry face. I mean, their emoji game is really, really weak. because that should be like an angry face, you know, and then it's like, and then neutral face, like, and then slightly happy and really happy, you know. It wouldn't be that hard to do that person, whoever drew these slides up, because it wasn't me. Okay, so yeah, you'd have different smiley faces. So you can understand why this is useful in South Africa, because we know our literacy level's not that good, and our language is all different. But you can kind of say how happy you are, indicating a smiley face. Okay, so forced choice. Tick 1 only. You are forced to choose one option. I dislike conflict, I avoid it. I feel neutral about conflict, or I thrive on conflict. I will search for conflict situations. Again, terrible, terrible instrument. Because who's going to say, oh yeah, I thrive on conflict, I look for it. Most people who thrive on conflict have no idea that they're looking for it. There are like two types of people in this world. There are the people who think the best drama is drama that is happening to someone else, and the people who've got binoculars sort of watching, like waiting to get involved, right? So, yeah, but this is one way of using a forced choice scale. So if you had to choose between these options, which one would you choose? And then the Guttman scale. My attitude about crime is based on my experience of an incident that happened in. And then you circle. And then you can add it up. Okay? But I need to read more about Guttman scales, I'll be honest. The only time I ever see or experience Guttman scales is in this class. Anyway. Yeah, they use them for contentious issues. Issues about contentious issues usually. Questions about contentious issues. Okay, designing a measurement scale. Don't need to go into too much detail about this. We've looked at a measurement scale yesterday. What are we trying to measure? Are we looking at one dimension or many dimensions of a construct? Usually we look at a lot of different dimensions at once. Will the item be formulated as a question or statement? So with the Likert scale we can use a statement. A lot of the time we can use a statement. Sometimes we use a question. Will the response labels have descriptors or just the extreme categories? Will the scale measure one construct or many? So it's dimensions versus constructs. How many response categories are needed? That goes back to the 5 versus 7 idea. Do we want a few options or do we want many? And will the scale lead to ipsative or normative comparisons? Now, broadly, we can go into scoring later. We do go into more detail. Normative, again, the word gives it away. Normative is comparing against the norm. What is normal? What is average or expected? And ipsative is comparing against itself. Okay, so ipsative assessment or scoring is against itself, and normative is against a group. Ipsative is usually ipsative or compared. It's a way of describing things, and the reason it's not compared against the norm is because you can't usually with ipsative scoring. Depends on who's using it. There's some ambiguity around those two words. Some people use ipsative to refer to any activity where you compare people's progress against their own progress, but that's not quite true. It's more to do with the scale design. But normative is the comparison, so that's comparing against the larger group. Now, wow, we're actually getting ahead. This is great. Now, this is a big relief. So dots can also be depicted graphically. I said to you earlier, graphics are pictures. The center of the distribution can also be determined by calculating the mean, the median, and the mode. Start paying attention now so that when we do this next week, you are familiar with these terms, because we're going to cover them from a statistical perspective. We're going to cover them as actual mathematical calculations. But let's start looking at them now. We like to be able to describe data. So what that means is we like to be able to summarize it and arrange it in a way that is easily digestible by others. So how do we communicate that data? First thing we can do is create pictures. So we can create pie charts and histograms and bar charts and polygons, and we can then show people what's going on. If I go back to my SPSS output, this is what you end up with. And you're permitted to not get as excited about this as me. But there, that's a histogram. with a normal distribution superimposed over it. And that's a very nice graph. That's a good result. Okay, that's all you need to know for now. So this is the sort of thing we actually use, and you can start looking at this. This one's also fairly pretty. You see, it kind of matches the line it was supposed to match. There's a problem. It spikes and drops. You can see that there's a slight curve, but overall it sort of tracks the same line as it's the predicted line it's supposed to track. Okay, so you can see there that if I go up to a scatter plot or down to a scatter plot, not enough points on that one. So that's human development, improvement in human development, and that's the predicted value against the actual value, and that's not a beautiful graph. That's also not a very beautiful graph here. Yeah. So scatter plot is one way of doing it. If I just show you a basic regression against a scatter plot, that would be, this one's upside down or sideways, but that would be what you would end up with. It's 2 points plotted against each other, and it gives us an idea of the relationship. In that case, not very much of a relationship, I'm afraid. Sometimes it doesn't work out so well. So that's graphics. It's summarizing things using a picture, and those pictures will make sense to you very soon, don't worry. I'll stop sounding like I'm speaking Greek. Okay, so the mean, the median, and the mode. Very important statistical concepts. They do form the basis of everything else we do. So the mean is the average. Okay, just put those two words together. Mean is average. Same as every average you've ever worked out. Make sense? So it's the sum total of all the scores divided by the number. And I'm boring you, and I shouldn't be boring you. Pay attention. This is scary. Okay, this is important. Do I have to say? I have chocolate. Will that work? Maybe that'll work. Okay, so the median is the middle value. So if you lined up all the values and you went to the middle value, that's the median. So say we lined all of us up from shortest to tallest, and we had our heights. The two people or the person in the middle would be our median value. That height would be the middle of the middle in terms of all the scores arranged from smallest to biggest. And then the mode is the value that occurs most frequently. So mode, you can think like it's like modern, it's like fashion, it's something that's trendy, so it's something that happens a lot. So the mode is the value that appears most often. Median is the middle, and the mean is the average. The position of the scores around the mean also gives us an idea of what's going on. If that standard deviation, okay, so let's start with the range. The range is the difference between the highest score and the lowest score. So if we look at a basketball team, we'd see that there's not a huge range in terms of their heights, right? They're all very tall. If we looked at the range in this class, the smallest and the tallest person, there'd be quite a large range in terms of the heights. Okay, so it tells us something about the distribution, about the type of spread or the differences we see. So if we looked at the ordinary population, we might see hugely different levels of conscientiousness or hugely different levels of anxiety. But if we measured you guys, we'd see fairly stable or consistent levels of conscientiousness and low levels of anxiety. So that tells us something about the population, and that tells us about our sampling, about how many people we should have in our sample, and it tells us about how accurately we can predict things too. Because if I'm making generalizations about the population, you can't actually generalize too hard. You can't say everyone is conscientious unless, you know, if I'm talking about a military population, I can. Because of that range, people differ. So opinions differ. You can't predict any South Africans' attitudes about issues like the death penalty, for example, because there's too big a range of opinions. So it would be very hard. You'd have to describe it more carefully. Okay, I'm not going to labor that point. The standard deviation is another very, very important point, and that is the difference, average difference between the average and each score in the distribution. So where do most scores sit? They sit within one standard deviation of the mean. So they sit on either side of the mean in quite a small distance. Okay, so that's the average difference between the mean and each score. We work out on the range where most scores sit. So if we know the standard deviation, for instance with IQ, we know most people sit between 85 and 115. That's the standard deviation, is 15. So they're going to be either between 85 and 100, which is 15 points below the mean, and between 100 and 115, which is 15 points above. We know most people will sit in that range. Okay, that's what the standard deviation does for us. It tells us now in South African population, maybe the standard deviation, okay, that one's standardized, but the actual variances in things like intellect and income are very great. Our standard deviation for salaries or for income must be huge in South Africa. Not so. Okay, most people earn very little and then some earn quite a lot. Okay. So two scores can be correlated, and then performance of one can also be predicted based on the other. And I've started alluding to that. I've started to show you scatter plots, and you will be able to calculate a correlation by hand and use a computer by the end of the semester. So you can look at the relationship between things. So, displaying data. If 5 potential trainee managers are assessed on a learning potential test to identify those who could attend a management development program, their performance would be illustrated in a bar graph. Okay, the example isn't showing up here, and I'm so glad because they got it wrong. They showed a histogram, and what we'd actually want there is to show them in a bar graph. Okay, I will show you examples of a bar graph when we get there, but a bar graph is a little bit different from a histogram in that there are gaps in between because they're different categories. So if I go to graphs here, let me build you a bar graph quickly. Okay, so this is an example of a bar graph. Let's take that and let's go something easy. Okay, this is a bar graph. This is a good use of a bar graph. So there, what the graph has done is global north and global south. There's a cutoff between global north and global south. You're either in the global north or south. Okay, you don't go global north, global north, global north, global south. Okay, so there's a specific, you categorized into one or other, or the other, you labeled. So that's why there's a gap between them. In a histogram, there's no gap because you go from one, it's almost continuous, into the next category when you move over that rounding point. So if you go from 4.5 to 4.51, you jump from one category to the other. Make sense? So then they sit next to each other because you can move across. You can't move across. There's no intensity in this. It's categorical data. It's not even ordinal. It's nominal data. So for nominal data and for ordinal data, rather use something like a bar graph. For continuous data, rather use your histogram. So that's one example of displaying data. This is measures of central tendency, and you're going to do this in more detail when we get to stats. So these are test scores. The test scores would be from left to right, from lowest to highest, and the frequency goes up the side. I think that the problem with this is it's quite hard to understand until you see it, until you actually understand it. But if we took all of our scores, and you will do this, and you build a chart like this, it's a lot easier to understand. But that's saying that most people scored that score, whatever that score was there, okay? And most people scored that score there. Fewer people scored that score. Okay, so we'll put tick marks on that. I just want you to be aware that that's one way of looking at central tendency. And I'm going to call it a day there because it seems to be very hot in here, and